Okay. Welcome everyone to today's workshop titled Fall in Love with Machine Learning. I'd like to take a minute and thank you all for joining us on Valentine's Day. I know it's not easy. Please make sure you're all muted unless you want to ask a question. Otherwise, please mute yourself so that we don't interrupt or disturb the workshop. So as I was saying, thank you all for joining us on Valentine's Day. It's going to be an interesting workshop. Today's workshop is about falling in love with machine learning. So I'm assuming everyone here is interested in getting into machine learning and learning more about that. Before we start, just wanted to remind everyone that we will have a draw at the end. And so if you'd like to enter the draw, please make sure you have your full name written on Zoom. Don't write your nickname, your iPhone 5 or whatever. Make sure you have your full name written. Noor, please make sure you mute everyone so that we don't have any disturbances. So I'd like to start the workshop by asking everyone, why are you here today, right? Why are you?
Chris, sorry, you're muted. So Noor, don't mute Chris.
Yeah. If you can put me as co-host, Noor, that would be great, please. Okay, so
just Chris,
don't send your name in the chat.
Writing their name in the chat.
Don't send your name in the chat. Just rename your user. If you have a user like your name on Zoom is not your full name, just rename it to your full name. Okay. So I see someone called Cherbil, for example, or Dana. If you would like to join the draw, please add your full name instead of just Dana or just Cherbil, right? This is what we meant. Do not send it in the chat. We already know that. Okay, so let's continue. Why are you guys here today? I'm guessing you are interested in getting into artificial intelligence. You're interested in AI, in the field of AI, and you would like to get into that field. However, you maybe have a problem with beginning. Like, I don't know where to begin in the field because it's such a big field that it can be a bit confusing. Or maybe you're lost with all the resources online because when you go and Google how to learn machine learning or intro to machine learning, there's tons of resources out there and it can be a bit confusing. You might have a feeling that you don't have a background needed for this field. Like I don't know mathematics. I'm not an expert in whatever, so I don't know how to learn it. Or maybe you just scared to take this step because it's such a big step that sometimes it needs a bit of courage. And so you're here to kind of get some encouragement to join the field. So the next question I would like you to think about is, what do you think you need to get started with machine learning? Okay, when I ask these questions to people, what do you think you need to get started with machine learning? Sometimes they tell me that I need a strong background in programming and I need a strong background in math to be able to get started in machine learning. I need a lot of time because it's a huge field, and for me to even get started, it's gonna require a lot of time. And I need a university degree. I hear this a lot. I need a university degree to be able to get started with ML. But actually, you don't need any of that. Today's workshop will prove to you that you don't need a strong background in programming or math. You don't need a lot of time, and you definitely don't need a university degree to start with machine learning. It's all about understanding the basic concept and getting your hands dirty with coding. So, as I said, during this workshop, we will cover an introduction to the world of machine learning and the basic concepts that we have. We will check out some applications of ML or AI in the real world in different industries. And more importantly, we will get our hands dirty and we will apply a machine learning model to build a small solution using code. So it's exciting. Let's get started. Before we get started, for those of you who don't know who I am, my name is Chris. I'm a software engineer. I have more than 12 years experience in tech or in software development. I've been involved in AI for, I think, 8 years now. I've worked on a lot of projects in AI. I've built a lot of solutions. And recently, I've shifted my career to become an AI educator and to help other people learn and get started with AI, because I found that this is the main problem with why we don't see a lot of AI adoption in the MENA region. So people don't really understand what AI is and how they can leverage it, and companies don't understand what it is as well. And so from this passion, I founded a community called Beirut AI, which is pushing AI in Lebanon and raising awareness. And then through Beirut AI and the activities we did, we scaled that and we founded Zaka, my current company, that's basically focusing on AI education across the MENA region. So we have a lot of exciting things at Zaka, a lot of programs to help people get started with AI. We can discuss those later. This was a quick introduction about my background. Let's get started. Before we start, actually, just one more thing. A lot of people need support on their journey in AI, and that's what we provide at Zaka. And so if you'd like to have some help, some guidance, you don't know where to start or you don't know what the next step is, and you'd like someone to guide you, you can book a free online call, a free consultation. Just go to zaka.ai/support. You can book a 15-minute call with our team, and we would love to help you, get started or figure out the next step on your AI journey. So now that this is done, let us get started. What is artificial intelligence? I know this is very high level, and I know everyone here has heard of AI, obviously, and sometimes people think they know what AI is. But I always like to start by mentioning or by defining what AI is, because I believe there's a misunderstanding, of people figuring out AI. So a lot of people, when I tell them artificial intelligence, the first thing they think about is usually robotics. They imagine robots, the robots that we see in movies or in science fiction. They see those robots taking human form and replacing humans. Sometimes they're evil. They're taking over humans' jobs, etc. While this is scary / exciting, it's not an accurate representation of artificial intelligence. If we really want to define AI, especially AI that we see nowadays everywhere we look, it's more like this. Okay, AI is more like a bunch of data points with a pattern. Okay, so a bunch of data points which you can see in the blue dots, with the red line, which is basically the pattern that we find in those data. So if you really want to define AI, it's not actually robotics as much as it is software. Okay, it's algorithms. And I'm hoping everyone here knows what algorithms are. But in case you don't know what algorithms are, a programmer, the way a programmer tells the computer how to behave is by giving instructions. It's by writing code that tells the computer, perform this step and then do this step and then do this step, etc. So we give the computer a series of steps to execute. And this is called an algorithm. Just like a recipe, if you want to bake a cake, you follow the recipe step by step and eventually end up with a cake. So the same thing, an algorithm is how we tell the computer how to behave. And so traditionally, programming is about algorithms, and artificial intelligence is the updated version of that. So AI is about smart algorithms. It's about building what we call intelligent algorithms, okay, that can perform the following tasks. So first of all, these intelligent algorithms can process large amounts of data. So just like any algorithm or software, it can go through data at a very fast pace. They can also recognize hidden patterns in the data. So not only do they process data, but they can find some pattern. And this is the beauty of these algorithms, is that they can learn to detect a pattern and then use this pattern for some prediction or for some decision making. More importantly, they can perform human-like tasks. So everyone knows that AI is simulating human intelligence or doing things that human can do. So this is what we mean when we say human-like tasks. For example, we know that humans can drive a car. We know that humans can play, let's say, chess. We know that humans can have a conversation and talk to each other. So there's a lot of tasks that only humans are able to do, up until we now have softwares that can do those things, right? So we now have a software that can play chess better than any human in the world. We have software that can drive a car by itself. We have software that can chat with us, have a conversation with us, right? Etc. etc. So these tasks were previously thought to be human-only tasks, but now we have software that can perform those tasks, and that's what we mean by those algorithms. Another point is that those algorithms can learn from experience. So instead of us having to give them exactly the instructions step by step, they can learn from experience, which means they can look at data and learn from the data they get. And finally, they can adjust to unseen input. So if they were trained on some data set, they've learned the pattern. Next step is they can answer or reply or predict or act on any new data that they can see. Okay. I see that there are some questions in the chat, so I'm going to address them quickly. You will have access to the recording session yet. The slides, no. Can we do that with normal algorithms? No, you cannot do that with normal algorithms. Normal algorithms, Bashir, you have to specifically tell them what to do, right? If you want to tell the algorithm to detect a cat in an image, how is that possible? You have to tell it exactly what a cat looks like, and every single pixel or every single shape or shade or whatever. But you know that cats can come in millions of shapes and colors and poses, and sometimes they're lying on their back and jumping or whatever. It's practically impossible to code it, in normal algorithms. That's why you use AI or machine learning algorithms. AI can play chess, but why is it hard for it to open doors? Well, because AI is not, fully capable of doing everything. In fact, Dalia, let me show you why that's the case. So there are 3 different types of AI that you have to differentiate between. Okay, guys? The first type is called a narrow AI. So narrow AI, there are systems that are built to perform one task and do it really, really, really well. Okay? So narrow AI can be an AI that plays chess or that answers questions online or that drives a car or whatever. They're very good at doing that, but they cannot do anything else. So in your case, Dalia, we can have an AI like Deep Blue that is great at playing chess, but it cannot open doors because it's narrow, it's limited, it's focused on this task. The next type of AI, we call them general AI, because these systems can generalize to multiple tasks. So they can play chess, they can open doors, they can drive cars, they can do whatever, right? There's plenty of examples of what they can do. And the last category, we call them super AI or super intelligent AI. And these are systems that can exceed humans in every possible way. So they are smarter than humans, they are faster than humans, they don't need human intervention to basically operate. So why it's important to differentiate between those 3 types? Because 99.9999% of the AI that we see today in our world is narrow AI. I know that you might think that we have super advanced AI and it can do everything, but actually it's still narrow AI. We are still building systems to do one thing only. When it comes to general AI, the only example we know or we have is us humans. We humans can generalize. We can drive a car and have a conversation and look at images, identify what's in them. We can do a lot of those things, so we can generalize. And when it comes to super AI, which is what everyone is scared about, this is only present in science fiction and in Hollywood movies. So we're far, far away from reaching super AI. Okay, guys? So that's why, Dalia, we can have an AI that is really good at playing chess, but cannot open doors because it's a narrow AI. Everything we're doing now is narrow AI. So I'm going to continue. If you guys have any questions, write it in the chat and I'll get to it as soon as I can. Do not write your name in the chat, guys. Rename your user if you're not writing your full name, just rename it. Do not write it in the chat. So now let's look at the different terms, because you've heard of AI, you've heard of machine learning, you've heard of deep learning, you've heard of data science. What's the difference and how do we address them? So first of all, let's start with AI, which is the biggest circle we can see. Artificial intelligence is a big topic or branch of science that includes a lot of subtopics. Okay, so AI is the branch of science that includes all the techniques that we have that makes our systems intelligent. Okay, whether it's software system or hardware system, anything that we're doing to make our systems more intelligent, we're basically doing artificial intelligence. So for example, robotics is part of AI, it's under AI, it's a subsection of AI. Machine learning, as you can see here in the image, is another subsection of AI. Okay, so what is machine learning? Machine learning is a group of algorithms. Okay, do you remember initially we said we have those intelligent algorithms that can process data and extract patterns? So machine learning is what we call those algorithms. It's a group of algorithms that are smart, that take data as input instead of taking instructions as input, and they process this data by applying some statistical methods on that. So we have AI, the big circle. Inside of AI, we have machine learning. And inside of machine learning, a subset of those algorithms, we have deep learning. So deep learning is a subset of machine learning algorithms. It's also algorithms that can extract pattern from data, but the way we do it mimics the human brain. Okay, so the way we do it is similar to what we have in our human brain, which I will explain in the next slide. So to recap about machine learning aims at developing algorithms to model human intelligence or to learn to perform predictions like humans can. So this is how it works very simply. We have data, okay, our data, which is used as an input to a machine learning algorithm. We take the algorithm, we take the data, we feed the data to the algorithm, and we learn a model. Okay, that's why we say it's machine learning, because the machine is learning the model that mimics the data. So we're learning that model through our machine learning algorithm. Once the model is learned, it means it can be used for prediction. So I can use it to predict on new unseen data, okay? We can use it to predict new things. So this is machine learning. And if you dive deeper into deep learning, as I just said earlier, deep learning is about mimicking the human brain. So if you guys don't know this, our brains are made up of neurons. Our brain cells are called neurons, and those neurons are connected together. We have billions of neurons in our brains, and each neuron is connected to a lot of other neurons in what we call the mesh or the neural network, okay? So we have trillions of connections, and they make our neural network, our connections of neurons in the brain. And this neural network is how we process information, and it's how we hold information. It's how we remember things. So in computer science, we wanted to mimic the same approach. So we created what we call an artificial neuron, and then we connected that neuron to a lot of other neurons. So we ended up with what you can see here on the screen, an artificial neural network. So what you see here is an ANN, artificial neural network, where every single node or circle is a neuron. And as you can see, the neurons are connected to all the other neurons. And now we have a neural network that can process information from one layer to the other, and it can extract pattern. Okay? Guys, if you write your name in the chat, you will be withdrawn from the draw. Okay, so please do not write your name. Let's keep the chat for the questions if someone wants to ask something about the content. Regarding the draw, it's all done. Please don't write your name anymore. Okay, so we discussed AI, we discussed machine learning, we discussed deep learning. Now, what does data science have to do with all of those things? So as you can see here, data science is a field that overlaps with all the other fields, okay? There's an overlap between data science and all the three fields because data science is the science of data, okay? So whenever we're dealing with data, we are doing data science. And as you already figured out, AI or machine learning or deep learning requires data as inputs. We cannot do AI without data. And therefore, we need data science to clean data, collect data, process data, prepare data, etc., to then make it ready for the model. So that's where data science comes in. Before I continue, let me answer the questions. Is there a limit to how far technology can take us? If not, how it can be infinite? Tala, this is an open-ended question. I'd prefer to leave it towards the end of the workshop because it cannot be answered in like 30 seconds. So if you have a question regarding those slides, write it in the chat. If not, I'm more than happy to stay at the end and have an open-ended discussion and discuss any questions you guys have. Maria said, what are the neuron equivalent in deep learning? Like, what are the nodes exactly? So Maria, the nodes, every node is a neuron. It's an artificial neuron that takes input, processes it, and gives us the output. I'm not going to go into the details of how it does that. It's outside of the scope of this workshop. But if you're interested, you can look it up. It's called deep learning or neural networks. So you can read about them and you can understand how they work. Muhammad, I will tell you what I mean by clean data in a minute. What about computer science? Does it overlap as well? Computer science basically is the underlying. So when we say algorithms, right? When we say machine learning, it's a group of algorithms. We're talking about computer science because algorithms fall under computer science. They're coding, right? You need to be able to write code to build those algorithms, and that's computer science. So is the neuron like a block of code that can do something to? Yes, exactly. In a way, it's like a block of code. What are the other parts of AI rather than ML, for example? No, actually, so AI has machine learning, can also include, let's say, robotics. It's another field of AI. There's a lot of things, but the main ones are machine learning, robotics. Computer vision or NLP is also a field of AI. So computer vision, when we make our computers understand the content of visual data, of images. Natural language processing or NLP is when we make computers understand text and communicate with us. These are also sections under AI. So before we continue, let's, okay, sorry, should we learn in depth all of AI? Okay, so I'm gonna answer this question at the end because this is more of a career support question. Now let's stay focused on the content itself. So we said that data science is the science of dealing with data. So let me introduce you guys to what we call the data science life cycle. So this life cycle, it basically summarizes the steps you need to take whenever you have data and you want to do something with that data. So you want to clean the data, prepare or process the data and then use it for prediction or for analysis. So what are the different steps you need to take? I'm going to go over them really quickly because again, you can dive into each step for hours, but roughly speaking, you always have to start with a business understanding. And this is very, very, very important because people think that AI is a magical solution that I'm going to throw at the problem and it's going to fix the problem by itself. But that's not correct. AI is a tool. Machine learning is a tool. We need to know how to use that tool to be able to leverage it and solve our problems. And so for that reason, if you want to solve a problem with AI, you have to first understand what is the problem that I'm trying to solve. What am I trying to do? So business understanding makes sure that we ask some questions. We say, okay, what am I trying to do? How do I want to solve it? Like what data do I need to collect? What is the approach? So we start by asking some questions that define our problem. Next step is step number 2, data mining, which is collecting or gathering the data that I need to solve this problem or to answer those questions that I asked in the first place. After we collect the data, there's data cleaning. And I think Muhammad asked me about it earlier. What does it mean to clean data? So Muhammad, we always assume that data is structured, is clean, is in the same format that we need it to be. But real life is not the case, right? It's very messy. So we always end up with data that has missing values, that has some inconsistencies, that has some errors, for example, null values, etc. I'll give you an example. Let's say we have users let's say today, right? You guys are joining this workshop and we sent you a form to fill. And in that form, we have a field called country. So tell us the country you're joining us from. A very basic example, if you're joining from Lebanon, there are many ways you can write Lebanon. Some people write Lebanon, some people write Leb, some people write capital L, L-E-B, some people write small letters, all in capital, whatever, right? So it's one example of how you can write the country name in different ways. And so ideally, you'd like to have a standardized way. So if you're joining from Lebanon, you write Lebanon that way. If you're joining from UAE, you write UAE. Do I write UAE or do I write United Arab Emirates, right? Do I write X or Y? So there's a lot of ways that people, deal with data. And at the end of the day, you would like your data to be structured, to be, in the same format, clean, well prepared, well formatted. And that's why you have to do cleaning. And data cleaning, let me tell you guys, it's the most underrated step in all of the data lifecycle. If you're working or if you're planning to work in the field of AI or data science, you have to keep in mind that 80% of your time will be cleaning data. It's going to be dealing with data. So if you don't like it, don't join this field. It's very important, guys. So after you clean data, you prepare your data, you then start exploring your data. So building or graphs, plots, figuring out the distribution of a certain feature, the correlation between features. There's a lot of things to be explored, but this is how you as data scientists will gain intuition about your data. So you need to understand how your data is built. So to be able to get some insight. And this is why data exploration is important. After you finish data exploration, it's time to move towards feature engineering, which is basically selecting the features you need for your problem. Okay, and this is done by after you build an understanding of your data through data exploration, you can then pick the features you need to use and proceed to the model or predictive modeling. Okay, so you do the feature engineering, and then finally you reach step number 6, which is predictive modeling, which is basically feeding the data to your machine learning model and start to see results. I know that these steps are a bit confusing and there's too much information, but if you stick with us until the hands-on workshop, which is in like 20 minutes, we will go through those steps one by one, and I will show you, what it means. So we're gonna apply everything we're talking about on an actual example in a couple of minutes. So just hang with us. So we pick the features, we then do the predictive modeling. We feed the features or the data to my model. Sometimes I do things multiple times. I try different things. I try different models and see which ones give me the best results. And finally, I reach the last step, which is visualizing results. So this is where I get my results and I need to look at them and show them to other people working with me, to project stakeholders or someone else, and see if these results make sense or not. And usually dashboards or visualizations are the best way to convey information. This is how we humans understand data. If you look at an Excel file that has 1 million rows, you cannot easily tell the distribution of users, if the gender distribution, let's say. You cannot say do I have more females or male. But if I show you one pie chart, you can easily say, okay, obviously there's more males than females, for example. So that's why we as humans understand things better when we look at visualizations. And that's why the last step is usually building dashboards or visualizations that can portray the results. And then after that, we go back to step number 1, because it's a life cycle. So we go back to step number 1, and we look at the questions that we initially set. Did we answer those questions? Are we satisfied with the results? If yes, then perfect. We can move on. Mission accomplished. If we found that sometimes we didn't get the right answer or something is not really as expected, then we have to go back and repeat some of the steps. Sometimes we can get more data. Sometimes we can jump directly to the cleaning part and realize that we have to clean the data better, or we have to explore it better, or we have to do some feature engineering in a different way. So we can try different things until eventually we reach a satisfactory result. So I hope this is clear. If not, please ask me the questions in the chat. And if you think I'm going too fast or you're not keeping up, please mention this in the chat. I can slow down, I can speed up, as long as everyone is understanding and we're all on the same page. So Maria asked, okay, Maria, I will answer your question at the end. So if you have a question about career steps, what do I need to do to go into the field, or can I do this if I don't have this background? All those questions will be answered towards the end. Right now, let's focus on the content itself. If you have questions on the slides, please ask me. If not, you can keep your questions until the end. We will answer them. I would like to know, what is data pre-processing? Data pre-processing is basically data cleaning. So you're basically processing the data, which means normalizing them, removing null values. So there's a lot of steps. To make it simple, we call it data cleaning. If you make it a bit more fancy, you can say pre-processing, but it's the same thing. You're just basically cleaning and you're preparing data to be fed into the model. That's what it means, Banim. Okay, guys. Where do things go wrong mostly? That's an interesting question, Bashir. Things go wrong. I mean, I wouldn't say wrong, but data cleaning, as I said, it's super important. So sometimes it's undervalued and not given enough time. So you might end up with data that is not well cleaned. And it might go wrong in predictive modeling. So one thing is very important in data science or machine learning. Always remember this, guys. Garbage in, garbage out. Okay, so if you feed garbage to your model, it's going to give you garbage as predictions or as results. And that's why it's important as data scientists to understand what am I feeding my model, right? So the data exploration and feature engineering are super, super important. So one of the things that might go wrong, Bashir, is that you feed, garbage to your model and it gives you some results and you think, okay, fine, it's giving me results. It means it's working, but it's not the case. So this is also important. Also, Mariam, data cleaning and data wrangling are almost the same thing. Again, I'm not going to go into the specifics, but most of the time, this step includes wrangling, processing, cleaning, working with data. So everything that has to do with making sure the data is ready for the model. So again, there's different terminologies in the field. It's a huge field. I'm trying to summarize it as easily as possible. So don't be confused with a lot of wording. Yes, Bashir, if you have data that is not clean, it will cause the model to fail. But what does it mean to fail? It's not going to give you an error. It's not going to crash your code. It's going to actually give you results, but the results will be garbage. It's going to be bullshit. Could we get relevant results by chance? Yes, you can, because if you have two choices, you have 50% chance of landing on one correctly. So there's a lot of chance. That's why it's important to understand the data, and it's important to have a good background in statistics to understand the results of your model. So it's, at the end of the day, it's a statistical model. So all it's doing is that it's predicting the probability of an answer being correct. So if you're predicting the probability, then it sometimes might have relevant results by mistake. Yes, definitely. Okay, guys, we need to stay on time so that we can finish everything on time. So let me pause the questions for now, go over the slides, and then we can continue. Where do we see AI today? Obviously, we see it everywhere. I'm just picking a couple of examples to give you an idea. Self-driving cars, a lot of companies, including one that's called Waymo, are building cars that can drive by themselves. They use computer vision, deep learning, and LiDAR, which is this sensor here on the roof, to understand the surrounding of the car and to make the car take decisions by itself. We see AI in virtual assistants, whether it's Siri, Alexa, Google Home, etc. There's plenty of those assistants. They all use different variations of AI, like natural language processing or natural language understanding to understand the command we give them. They use voice recognition to hear the command and to kind of compile it or translate it into text, and then text to speech to reply to us with an answer. So these are some forms of AI. We see AI a lot in social networks like Twitter. So Twitter, for example, the way it ranks the tweet in our feed is not random. It's actually, it looks at every tweet. It tries to understand the content of that tweet using NLP, natural language processing. And then it tries to rank the tweet in basically an engagement. So it knows what I'm interested in, and it shows me the tweet that I'm more likely to engage with at the top of my feed. And so it ranks them by the likeliness of us engaging with them. And that's how they can maximize our time spent on these apps. So Twitter and other social networks, they use a lot of AI to show us the posts in our feeds. We see AI used in agriculture. So this is an example of a robot that basically goes over the plants. It uses computer vision to detect every plant, and then it uses some also advanced models of computer vision to understand what every plant needs. The plant needs, let's say, water, it can give it water. If it needs herbicide, it can give it a microdose of herbicide. So instead of, in the old ways, the farmer used to water everything together and then spray herbicides equally. So one solution fits all. But in this case, we can move towards something we call precision agriculture, which is basically giving every plant exactly what it needs using AI. recommender engines are used a lot, whether you're doing shopping on Amazon or other e-commerce websites, or whether you're watching Netflix or listening to Anghami or any of those content-heavy websites. They use recommender engines to understand your preferences and to give you recommendations of things to buy or things to watch or things to listen to. Okay, so recommendation engines are basically everywhere, and I'm sure you've encountered one in your daily life. So George said there's a new algorithm in Twitter. The new one is based more on our replies than on what we like and retweets. Yes, but at the same time, it knows what you like, George. It knows that if you're interested in AI, it's going to show you a tweet, the way it ranks them is in that order. Another example is sentiment analysis, which means basically figuring out the sentiment behind some text. And this is used a lot by companies who have products online. If you have a product, you'd like to know what your users are saying about your product. Are they happy about it? Are they angry? Are they sad? Are they excited? Do they like this feature? Do they not like this feature? So the way you do this is you take their comments or reviews, you pass it through an NLP model, and you can classify them into happy, sad, angry, whatever. And this is called sentiment analysis. Now, I want to tell you about a new wave of AI that's called generative AI. I'm sure you've heard of them because they've been making mainstream headlines for the last 6 months. So generative AI are a form of AI that can generate content. Okay, you give them a prompt or a sentence, and it can give you a certain piece of content. So when it comes to images, I'm sure you've heard of DALL-E, Midjourney, Stable Diffusion, Imagen, plenty of others. All of these models, you give them a prompt or a sentence to describe what you need, and it creates the image that you're looking for. For example, you can say, Panda, mad scientist mixing sparkling chemicals, art station. You give it that sentence, it gives you this image, right? All of those images here were drawn by an AI, and it can do much, much more than that. You can change the style, you can change the content, etc. Same thing can be done with text. I'm sure everyone here has heard of ChatGPT, right? What is ChatGPT? It's a chatbot basically, but it's actually chat wrapping over a model, which is called GPT. And this model, it generates text. So you ask it a question, but actually it's generating text as an output. So it's all about text generation. And the last example is also we can use it to generate music. Now there's nothing completely out there yet, but Google and OpenAI and other companies are working on models where you can describe what you need. For example, I want a song that's sad, that has the style of AC/DC, blah, 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 blah. It's going to generate the song for you, the music, right? So it learns to generate based on what you give it as description. Yes, believe it or not, Lamar, all of these are still narrow AI. Even ChatGPT, it's narrow AI. Exactly. So ChatGPT is great at answering your questions, at generating text to make you think or to make you believe as if it's written by humans. But can you ask ChatGPT to drive a car? Or can you ask it, I don't know, about to play chess? It cannot. All it can do is answer in text, right? Of course, it's very advanced. It stimulates intelligence in a great way, but it's still narrow AI. Okay, I'm not going to show you this because no one understood what it meant. So let's move on. Now, to go back to our machine learning, today's workshop is about falling in love with machine learning, right? So I'm assuming everyone here is new to the field. So let me quickly tell you what are the different types of machine learning. We're going to cover a couple of algorithms, and then we're going to jump to the hands-on coding part. If you think I'm going too fast, or if you have any questions, please mention it in the chat. Otherwise, let's keep going. So machine learning is a group of algorithms, right? And we can group those algorithms into 3 main categories. We have the supervised learning algorithms, we have the unsupervised learning algorithms, and we have the reinforcement learning algorithms. So what is supervised machine learning? Supervised machine learning means that I'm trying to, the data that I'm feeding to my model is it's called labeled data, which means the output labels are known, okay? So In that case, I give the model my data, I give it the input, and I give it the output because I know what the output labels are. And the model is learning to make association. So, for example, like you can see here in the GIF, I'm showing the model, which is represented by this robot. I'm showing it pictures of dinosaurs, and I'm saying this is a dinosaur. It says, okay, sure. And then I show it another picture. I say, this is a dinosaur as well. So the word dinosaur is the label attached to the image. And I say, okay, this is also a dinosaur. So the model is saying, okay, I think I know what a dinosaur looks like now. When it sees a new dinosaur, it says, okay, I know what this is. This is a dinosaur. Okay, so it learned to identify dinosaurs by looking at pictures of dinosaurs. And the word dinosaur is the label I attach to my data. Same thing can be done to any other data. So whenever I have labeled data sets, I am doing a supervised machine learning approach. Now, in supervised machine learning, I have two types of tasks. I can either do a classification or I can do a regression. A classification, just like the name says, is when I'm trying to predict a class, okay? So like the example of a dinosaur, assuming I have a model that learned different animals, I want to show it a picture of an animal and it has to tell me, is this a cat or a dog or a dinosaur or whatever? So what it's doing is actually classifying the input into one of the categories. So it's predicting a discrete value, 1, 2, 3, 4. It's predicting a class. So a great example is what you see in your inbox, right? Every time you receive an email, there's a small classifier in your inbox that looks at the email and says, is this a spam email or is this a no spam email, right? It classifies between spam or no spam. And this is called a classification. The other type of task we can do is called a regression. So in this case, I'm not predicting a category, I'm predicting a number. So the output is a numerical output and it's a continuous value. Instead of this being discrete, like A, B, C, or 1, 2, 3, I'm predicting a value between whatever, 0 and infinity. So I'm predicting a quantity or an intensity, okay? One idea can be predicting the price of a house based on some features on that house. So if you tell me, for example, the location of the house, the number of rooms, I don't know, some details about that house, I can build a model that learns to predict approximately the price of that house. So this would be a regression, okay? I would be doing regression. Quickly, if you want to also understand the difference, classification, if you visualize it, it looks like I'm finding the line that separates a class 1 from class 2. So I have the blue dots and then the red dots. And classification is finding the line that separates both. Versus regression is finding the line that represents most of the points. So what is the pattern here? Okay, it looks like this. So this is the line that I found. This is my model that represents the data pattern. So this was supervised machine learning. So what does unsupervised machine learning mean? So if supervised means training with a labeled data set, unsupervised means I have data, but I don't have the labels. So it's unknown. The labels are unknown. For example, assuming I have this bunch of data that is not labeled, it's just data that joined together randomly. I give this data to an unsupervised learning algorithm, and it gives me those groups or clusters of data. So it learned to group data together based on similarities, based on the data that looks alike. And as you can see in each cluster, the data is similar. They look alike. So without knowing what class every data point is about, it learned to cluster them together. Sorry, and this is what unsupervised machine learning is. And the last example, which is reinforcement learning, and this is very interesting. It's when I have a certain agent, okay, an AI agent. I put this agent in an environment, and I let it engage with the environment. Every time this agent takes a certain action on the environment will return, will update the state. Obviously, it's gonna change because the action is affecting the environment. So the agent takes an action, the action affects the environment, and the environment returns a reward to that agent. And then by learning to maximize the reward, the agent is learning to behave correctly. And this is called a reward mechanism. A quick example of how you can understand this. Imagine you have a dog and you'd like to train that dog for some tricks, right? If you say sit, you want the dog to be able to sit. So you keep on saying sit, sit, sit. Every time the dog sits, you give it a treat. So you are giving it a reward. And it's this reward mechanism that teaches the dog that, okay, when I hear the word sit, I have to sit. It's kind of like that. And reinforcement learning, we see it a lot in games, because games are a great example of an environment where I have some rules. You have to move up, down, left, right, whatever. You have to avoid obstacles or something. And you also have a reward, which is the score. So this example here, it's an AI that was trained, or that actually learned to play Pac-Man just by playing Pac-Man. So no one gave it the rules. We just told it, you can go up, down, left, or right. That's it. And we told it to maximize the score. So it started moving randomly. And every time one of those ghosts hit it, the score would go back to 0. So it learned that this is a bad move. I have to avoid it. And after doing this for millions of times, eventually it learned how to play Pac-Man without even understanding what Pac-Man is or what are the rules of playing Pac-Man. Is this how self-driving cars work? It's actually a combination of many things. Self-driving car is not one AI model. You have a model that detects objects through computer vision. You have multiple models that do the decision making. So it's not as simple as that. Yeah. So to continue, guys, let's cover some of the classification algorithms that we have before we jump into the hands-on coding exercise. So if you remember, we said we have supervised machine learning. And then in supervised machine learning, we have two types of tasks. We can either do a classification or we can do a regression. So today we're going to focus on classification and look at some algorithms to classify. The first and simplest algorithm is called logistic regression. So although its name contains regression, it's actually a classification algorithm. It's used for binary classification problems. Okay, the idea is that we have at the end of the logistic regression, we have what we call a sigmoid function. Okay, that looks like this. This is the sigmoid function. The sigmoid function has one job, which is to map the values between 0 and 1. So for any x that you give it, whether x it's minus 300 or it's plus 5 or it's infinite, whatever you give it on the x-axis, the y value is either, it's between 0 or 1. It cannot go less than 0. It cannot go more than 1. So it contains, or it squashes the values between 0 and 1. And that's why we can use it for for classification, binary classification, because at the end of the day, my output has to be something either 0 or 1. If I'm predicting if an email is spam or not, then it's basically spam or no spam. So I have two cases, and that's why what sigmoid helps me to do, helps me map it to 1 or 2. So the way that we usually do this is the output of the model, okay, of sigmoid is basically a certain value, let's say 0.7 or 0.2. And what I do is I map it to either 0 or 1 by considering a threshold, which is 0.5. So 0.7 is closer to 1. So I map this as 1. If it gave me 0.2, then I say it's closer to 0. So the class would be 0 in that case. 0.6, 1, 0.4, 0, just to give you an idea. And that's how we can build a simple model that can predict class 0 or 1. So basically A or B. Exactly, Muhammad, we are rounding the output of the function to either 0 or 1. I hope this is clear. I hope you guys are still following and you have no questions. Let's continue to the second type of algorithm, which is called K nearest neighbor. Okay, KNN, or K nearest neighbor. If it's 0.5, Marianne, it means the model hasn't learned anything. It's still predicting randomly, because what are the probability of something being either A or B? It's 50% A, 50% B. So if it says 0.5, it means it did not learn anything, right? It means model is not learning. And usually we don't have it. Usually when a model is learned, you get something like 0.7, 0.8, 0.1, 0.2. So you get closer to the extremes. You don't get 0.5. If you got 0.5, it means your model is not well trained. The binary one isn't that accurate though. I mean, these are all linear models, so they're not the most accurate models out there. Let's talk about the limitations at the end. I want to make sure that we still have time for the coding parts and for the draw at the end and to have some questions. So let's keep it for the end. Okay. So the second algorithm, guys, it's called K nearest neighbors. So it's also a classification algorithm. So it's meant to classify a certain data point or certain inputs into one of the classes. So the way it works is that it looks at the K most similar examples in our training examples, and it tries to classify the inputs based on those similar examples. Okay, and this algorithm assumes that things that are close to each other are similar to each other, or actually things that are similar exist in close proximity. This is the idea. So if two things are close, it means they're similar. Or if two things are similar, it means they should be close. That's the idea behind K nearest neighbors. So how it works, the way it works is the following. Imagine you have initial label data, okay? So you have those blue squares, okay? I have blue squares, and I also have red triangles, okay? These are my two classes. And then I get a new data point, which is this green dots. So I have blue squares, I have red triangles. These are the two classes. And then I have a new point that I have to classify, which is this green dot. Is this a red triangle or is this a blue square? The way we do it is depending on the value of K. If we decide K, which is K is a parameter, right? So K can be 3, it can be 5, it can be 2, it can be 6. Assuming K is 3, I look at the 3 closest data points, okay? If I look at the 3 closest data points, I have 2 red triangles and 1 blue square, which means there are more triangles than blue squares, which means this green dot is basically a red triangle. It belongs to this class. But if K was equal to 5, then in that case, I look at the 5 closest neighbors to this point, to this green dot. And in this case, I have 3 blue squares and 2 red triangles, which means the blue squares win, and this dot is actually a blue square. Now you might be thinking, if it all depends on the value of K, how do I decide which value of K to use? There is a method. Basically what we do is we try all the values. We pick, let's say, from 1 to 10. We try all the values for K, and then we plot them. And then there's something called the elbow method. I'm not going to go into it right now. It's a bit, it's not too advanced, but it requires a bit of time. But there is a way for us to figure out the best value for K to be used in an algorithm or in a data set. Okay, but assuming that we know what the K value is, we can just replace it, and that's how we are able to classify a new data point. What if we have 3 red triangles and 3 blue squares? Well, I mean, usually K is chosen as an odd number. Sorry, so K is an odd number. If it contains, let's say, equally, you just increase the value of K, because at the end of the day, you need to make a decision. So if it's really equal, increase K by 1 and see what you get, right? You should be able to get at least one of those, and then this would be the winner. Again, these are not the perfect classification algorithms. There are a lot of fallbacks or pitfalls for these algorithms, but they do work. They work quickly and they work reasonably well given the simplicity that they have. Okay, so remember, these are what we call linear models, and they're not the most advanced or the most accurate models out there. Of course, when we talk about deep learning, it's much more advanced, and they can perform much better in terms of accuracy. And the last example, or the last classification algorithm we'll look at today, is called decision tree. So decision tree is a supervised learning algorithm that can create a model that can work on either regression or classification problems. So it can work on both. Okay, it's very simple. It works by building a tree and making decisions based on that tree. So we have 2 parts in that tree. We have our nodes, which basically are the red square, and we have our branches, which connect the nodes together. okay? And we start with an initial root node, and then we do have what we call internal or split nodes. We can have multiple layers of split nodes, and finally we have our decision nodes or leaf. So we start with a root node. We can split multiple times between the roots until we find eventually the decision or the leaf nodes. Now, how does this work? It's very easy. We always split on a condition, okay? So I start with a certain condition. If the condition is met, I go here. If it's not met, I go to the right side. So condition met, left, condition not met, right side. Then here there's another condition. Is it yes? Is it no? I keep doing it until I reach my final decision. Now let me give you an example for everything to make sense. Imagine I'm trying to classify animals, right? Into whether it's a hawk, it's a penguin, it's a dolphin, or it's a bear. So first I start by asking the first question, does it have feathers? If yes, then I go here into this branch. If no, I go into that branch. So yes, it has feathers. Okay, fine. Can it fly? If it can fly, then it's a hawk. If it cannot fly, then it's a penguin. So penguin is an animal that has feathers but cannot fly. But if it does not have feather but it has fins, then it's a dolphin. If it does not have feather and does not have fins, then it's a bear. And it's a simple example of how we can classify based on some decisions. Exactly. It's like a nested if-else system, exactly, except that you don't give it the if-else conditions yourself. They are learned from the data that you have, okay? And that's the beauty of it. If you put it as if-else yourself, in that case, you don't need machine learning. You can do it with a basic coding algorithm. But sometimes you don't know what the features are. You don't know what the conditions are. And they're not as simple as yes, no, right? This is a very basic example. Sometimes it's like, if this value is less than 0.5 and more than 0. Whatever, then it's, so there's a lot of features and intricacies to those things. And you don't have to figure them out yourself. You can put them and let the model figure them out by itself. Does it contain a binary tree or any kind of tree as long as it, yes, it's kind of like a binary tree in a way. It's splitting on the conditions. Can you do this binary tree? Yes, you can. Again, you can do it, guys, manually. But again, you will have to put the conditions yourself. However, sometimes you don't know what the conditions are. That's why we use deep learning or machine learning. We use it whenever whatever we're trying to program cannot be done in normal coding. Okay, if it's that simple, obviously I don't need machine learning. Obviously, I can write a couple of if-else statements and classify the animals. But as you will see right now in our code, sometimes you don't know what the conditions are. So after I train the model and build this tree, you can see that these would be the features. So feathers, fly, fins are my features, and the lower layer is my label. Okay, it's the leaf or leaf nodes or decision nodes, which are my labels. Okay, so finally, it's time to jump onto the hands-on workshop. What are we going to do in the hands-on workshop? So we have, I'm going to try to predict the price range of a cell phone. Okay, I have a cell phone. I have some data on that cell phone, some information, and I would like to use that info to predict the price range. So my input data, I have info about cell phone like battery power, clock speed, number of cores, number of RAM, Wi-Fi, etc. And my output would be low cost, medium cost, high cost, very high cost. So I'm not predicting the number itself. I'm not predicting the price. I'm predicting the range of the price, which makes it a classification task and not a regression task. Because if I'm predicting the price, this phone costs $200, this costs $500, whatever, I would be doing a regression. But because I'm predicting the range, then it's a classification. It's either a low cost phone, medium cost phone, high cost phone, or very high cost phone. So to do that, I'm gonna send you a GitHub link on the chat, okay? And when you open that link, you will basically land on this repository, which is our machine learning for beginners repo that has the data set and that has the Colab. So the issue is, guys, the issue, guys, is that I might be going a bit fast to be able to finish on time. So if you'd like to, if you prefer to watch me go through the code and write the code myself, then that's totally fine. You can always do it later after the workshop. You can take time and repeat the steps we did by yourself. The cool thing about this workshop or about this repository is that it includes a Colab with blanks, so a code that has missing code, and it includes the full code underneath it. So do not look at the full code right now, ignore it. Click on the first link to open the code with blanks, okay? This is what we will be doing today. And later on, if you don't want to do it now, if you just want to watch us, you can repeat the steps later on. You can go over the blanks, Colab, do the steps by yourself, and then finally go back and look at the answers. So next step is you have to click on File. If you're doing it with me right now, click on File, save a copy in Drive, so that you can work on your own copy of that notebook. Because this notebook is created by me and I'm the owner. So you will not be able to write anything. You will not be able to change it if you're not using your own copy. So after you click on File, save a copy in Drive, it's gonna create a copy and allow you to work with that. One more point, we are using Google Colab. If you don't know what Google Colab is, I'm gonna quickly explain it, but I don't have time to go through the details of everything. It's basically Jupyter Notebook with on Google Drive. So if you're using Jupyter Notebook before, if you've used it before, sorry, it's a way where you can write Python code, execute it in the browser, and get some results. So Google took Jupyter Notebook, they put it on Google Drive, and they called it Google Colab. It's a very easy and free way to write code, Python code in your browser and execute it and do some processing with it. So before we start, we have to click on Connect here to basically get a Google VM virtual machine that's going to run our code. And after a couple of seconds, you can see it says connecting, and finally it's going to connect us to a Google virtual machine on Google Cloud that's running Python, where we can write our code and execute it. If you zoom in here, you can see it says connected to Google to Python 3, sorry, connected to Python 3 Google Compute Engine backend, and it shows the amount of RAM and disk space. Okay. So any questions so far? I don't want to be going too fast, guys, but if you have any questions, just write it in the chat. I'm more than happy to stop and repeat. If we don't have questions, I'd like to keep going so that we can finish on time and then leave time for the most important part, which is the Q&A at the end. So we are 215 people right now in the workshop, and I'm hoping everyone is still aligned. I'm hoping everyone is still following and it's all clear. Let me remind you of what we are doing right now. We have a data set that includes the following columns, the following features about phones. It includes battery power, total energy a battery can store, etc. It includes Blue, a feature called Blue, which is basically whether the phone has Bluetooth or not. It includes clock speed. It includes dual SIM, FC, which is the front camera, 4_G, which is if it has 4G or not, int memory, internal memory in gigabytes, MDEP. There's a lot of features. I'm not going to go over them one by one. Of course, if you're doing the actual work as a data scientist, you have to understand every feature. But right now, all we have to know is that there's a bunch of features ranging from camera, clock speed, RAM, size of the screen, pixel width, pixel height, Wi-Fi, touch, no touch, etc. There's a lot of things. And more importantly, we have a feature called price range, which is our output feature. That's the feature we're looking to predict. And it has 4 values. It has 0, low cost, 1 meaning medium cost, 2 meaning high cost, and 3 meaning very high cost. Can we make it with decision tree and we add the cost of the... Yes, you will see, Karim, at the end. We will try all the different models. But before we jump to the predictive modeling step, remember, we have different steps in our data science lifecycle, right? Quickly speaking, for those of you who don't remember, this is it, right? we have different steps. We just started with the business understanding. We defined what are we doing, right? What is it that we're doing? What we're doing is we're trying to use these input features to predict the range of the price of that phone. This is exactly what we're doing. So it's very clear what we're doing. In terms of data, we don't have to mine it. I already have the data set I'm going to show you. So we're going to go through the steps one by one, okay, before we get to the predictive modeling, which is what you mentioned, Karim, in terms of using algorithms and predicting the price. So to get started, we first have to import the libraries that we're using. We're going to use NumPy, we're going to use Pandas, and we're going to use Matplotlib. NumPy is a numerical computing library, so we use it to compute anything to do with computations. Pandas is for dealing with data. Matplotlib is for plotting visualization. Then the data set itself is hosted on the GitHub repository that I sent you. So there's a folder called, I think, data, or there's a CSV file inside of it. And to get this file on our machine, we have to call git clone. We have to clone our GitHub repository to have it here. So if you open up the Files tab, you can see now we have a folder called Phone Price Range Prediction Workshop. That's it. And we have a CSV file called mobile prices.csv. So this is our data set. It looks like this. It's basically like a table, like an Excel file with column and all the values underneath it. This is our data set. Next step is we need to use Pandas to read this data and to explore it. First of all, we have to define the path of the file. Okay, so the path is basically we have to call the name of the folder. So phone dash price dash range prediction workshop slash, wait, I forgot the name of the file. So it's phone price range prediction workshop slash mobile underscore prices.csv. So the name here is mobile underscore prices.csv. And that's how I just pointing to the file itself. I don't know if you should be able to do it with an iPad, but it's not ideal. So next step is after I define the path, I call PD, which is pandas.readCSV, and I point it to my path, to the file itself. And this will basically read the file into a data frame. And to display the first 5 rows of data frame, we have to call the function head, the f.head. I'm not going to explain exactly what it is. If you don't know what head means or what df means, df is data frame. So Pandas, when you load a certain CSV file, it loads it into a data structure called data frame. You can think about it as if it's an Excel file. Okay, similar to an Excel file. It has columns, it has rows, it has columns and rows basically. And the cool thing about df or data frame is that it allows us to slice data, select data, and work with data easily. So Marianne, to clone it, you just ran this command, git clone, and the URL of the GitHub repository. That's it. Next step is to get the shape of our data set. We have to use df.shape. So if I call df.shape and I print it, the shape is 2000,21, which means that I have 2000 rows in my data set and 21 columns or 21 features. Okay, that's the shape of the data set. So our data set contains 2000 rows and 21 columns. To get information about every column, we have to call df.info, the info function. The info function tells me that here are the columns. Okay, here's the name of every column: battery power, blue, clock speed, etc. And it tells me the amount of non-null values for every column, which means if I ever have null values, it shows me here that I have null values. Luckily, I don't have null values. I have 2000 non-null values for every single row. You can also notice that all the rows are integers except clock speed and mdep. These are floats. Okay, so they have a floating point as values. Next step is we start the EDA or data exploration. What if some data are strings If the data were strings, Karim, we would be seen here as object. It would not say int or float. It would say the type is object. Because it does not say that, it means that all my data is basically numbers. They're either integers or they are floats. That's basically the idea. Okay, so now we need to start visualizing the data sets. We need to start building intuition. And to get started first, we have to visualize the distribution of some categorical variables. So our variables, there are two types of variables when we're working with data. You have numerical variables and categorical variables. Numerical variables are, of course, numbers, and the categorical variables are categories, okay? Even though they might be, the type might be integer, but the idea might be categorical. For example, price range, we know that it has values 0, 1, sorry, it has, I think 1, not 0, right? No, sorry, actually 0, yeah. So it has 0, 1, 2, and 3. So the value itself is a number. However, 0 stands for low cost, 1 stands for medium cost, 2 stands for high cost. So it's not like an actual number. I cannot say medium cost plus medium cost equals high cost because 1 plus 1 equals 2. It doesn't work that way. It's just a number that identifies a category. So these are called categorical variables. Okay. And so to see the number of examples having a particular value, we use this format. So the f of variable dot value counts. Okay. So in my case, if I want to do it for the clock speed variable, I call the f, which is my data frame. I open up the brackets and I specify the name of my column. So I'm looking to visualize the clock speed. I select clock speed. So the f of clock speed, this notation will actually highlight or select the clock speed column. It's like I'm selecting all the values of that column. Then I click on dot and I write the function value underscore count. What the value counts function would do is that it's going to create what we call the frequency table. So it's going to go over the clock speed. It's going to highlight the unique values. Okay, so what are the unique values for the clock speed and how many times every value was found? So what is the frequency of that value? Let me run it and show you what I mean. When you run the code, you can see here 0.5 for 413, 2.8, 85, 2.3, 78, etc. What does that mean? It means that these are the unique values for the clock speed. I have 0.5, I have 2.8, I have 2.3, I have 2.1, I have 1.6. These are the different values that exist in this category. And for every value, how many times it appeared in my data set? So 0.5, it appeared the most amount of time, 413. So there are 413 phones with clock speed equal to 0.5. And there are, for example, 28 phones with clock speed equal to 3.0. That's how you can tell. Now, of course, it's better to visualize things visually instead of looking at numbers. So to plot these values using a bar plot, we call clock speed value counts, which is basically here, the data frame holding those values. I call it, and then I call dot plots dot bar. Okay, as simple as that. And then using matplotlib, it's drawing the following plots, which basically visualizes everything we saw here. Okay, so as you can tell easily by looking at this plot, is that 0.5 has the majority. Like there's a lot of phones having 0.5 as clock speed, and then the rest almost equal. So there's equal distribution of the clock speed for everything else, except for the 0.5. So that's something to keep in mind as data scientists. Next step is let's plot the value counts for the FC variable. So do the same thing for the front camera in megapixels, but this time do it with a horizontal bar plot instead of vertical bar plot. So to do this, the f of FC, we select the column, we then call dot value counts, we then call dot plots, just like we did earlier, and then we call bar h, the name of the function. It's okay if you don't know them, the function names, and you don't have to memorize them. eventually you can just Google everything you need. So if you need to draw something, you can go to Google and just say matplotlib, how to plot values in bar plot, for example. And you can look at the documentation and you can find everything you need, right? So don't be afraid that I don't know this function or I don't remember this, as long as you understand why we're doing it and how we're reaching it, okay? So we run the code here. And you can see for the front camera, this is how it looks like. We have like the majority of phones have a 0 megapixel front camera, which means they don't have a front camera. And then we have 1, 2, 3, 4, 5. So, so the higher the quality of megapixel camera, the lower the number, which kind of makes sense, right? Because most phones, let's say, don't have advanced features. So most phones have low-end camera. Should we do the same thing for every attribute column? I mean, it depends, Banin. Of course, what we're doing right now is a very quick and simple exploration. Usually, you spend a lot of time going through the data, as long as you build an intuition and you understand how your data is made up. So that's why I'm not gonna, the reason why we did those steps is because we've already went through the exercise and we've prepared it. But usually you try everything. You try to look at every column, every feature. You plot it. You look for correlations. You understand it better. But right now we're just doing things rather quickly. So for example, here the next step is we're going to do the same for the PC variable. Okay, for the primary camera instead of front camera. So to do the same, I'm just going to copy this code, and I'm going to paste it here, and change the name of the column from FC to PC, because PC, if I'm not mistaken, let's double check here. PC is the primary camera megapixels. FC is the front camera. So the column name is called PC. I go back here, I select PC, and then I plot them with a horizontal bar plot. And you can see it's more or less the same. Okay, there's no like here this ramp that's building up. You can see that when it comes to the front camera or the primary camera, sorry, it's more or less the same. They all have kind of equal, roughly amount of megapixels. Now let's plot the value counts of the number of cores variables, but this time using a pie chart. Okay, so what we're doing is we're selecting the number of cores. We're calling the value count, so getting the frequency table as well. And now we're plotting it using the pie plot. So there's a lot of ways we can plot. Pie plot is when you draw a pie and then we draw the distribution with respect to each other. And here you can see easily how they're equally distributed. So among all our data sets, we have almost equal amount of phones with 7 cores, with 2 cores, with 1 core, with 6 cores. So it doesn't really change. And pie chart is a good way to visualize how the distribution of one category relates to the other. Okay, so if you want to do the price range for the the same thing for the price range. Okay, you can copy the same code and then just change the name of the category from N cores to wait, is it price range? What is it called? Second, yeah, price underscore range. Perfect. So price underscore range, and now this is our output column. And you can see how it's distributed, and you can see it's exactly the same. So we have in our data set, 25% of our phones are low cost, 25% are medium cost, 25% are high cost, and 25% are extra high cost or something. So it's equally distributed, which makes it a balanced data set for classification, which is really good. Visualize the distribution of some numerical variables. So now, looking at numerical variables have to be visualized in a bit different ways. You cannot do them in categorical or in pie chart like categorical variables. We have to plot them using what we call a histogram or a distribution, we call it. So in this case, we need to plot the distribution of the battery power. And it's as simple as selecting the battery power column and then calling the hist function, the histogram function. And histogram function will basically show us the frequency of every value. So it's like, for example, 600 mAh or milliampere batteries. They were the frequency of them in our data set is 220, let's say. 800 is like almost 210. So you can see that almost equal in terms of the different battery power, right? So there's no mismatch between specific battery power or not. So Karim asked, should the histogram look like Gaussian distribution, or it depends? It depends on your data, Karim. If the variable that you're plotting has a normal distribution, then it will definitely look like a Gaussian distribution. If it does not, then it will not. So it actually depends on the data that you have. Now, what's more important than just drawing and visualizing variables is actually studying the correlation. So how do these variables correlate to each other? Okay, how does one affect the other? And to do that, we use scatter plots. Okay, scatter plots are comparing two values against each other. So in this case, let's compare the battery power to the price range. So plt.scatter, and then we have to specify the data for the first column, which is battery power. So battery underscore power. And then the second one is price underscore range. Okay, and you're gonna plot them together to see if does the battery power affect, or there's a correlation between price range and battery power. So look at how we can interpret this this plot. We have here the battery power, okay, and we have here the price range 0, 1, 2, 3. So if you look closely, okay, it's not well visualized, but if you look closely, for the 0, which is the low cost, you see a lot of points here. There's a lot of it's darker a bit, right? And there's less points towards the end. Okay, and the opposite is here. So in the very high end, you have less points here than here. What does that mean? It means that for the very cheap, low-cost phones, the majority of the battery is 600, 800. So the lower end of the batteries. When it comes to 1,800 or 2,000, we have less examples. We have less data. And when it comes to the high end, the very expensive phones, we have fewer phones with a small battery, like 600 or 800, and you have more phones that have higher battery capacity, like 2000. So it's not a strong correlation, but there is a correlation between the battery power and the price of the phone. And yes, Ali, it does make sense, of course. So next step is let's see the effects of the N-cores on the target variables. Target variable is the price range. This is the target. This is the variable we're trying to predict. So I'm going to copy this and just change, instead of battery power, N-cores. So do you guys think the number of cores would kind of affect the price? According to what we have here, it's actually, I mean, you said yes, but the data says otherwise. Okay, the data says that it's mostly the same. There's no effect on the number of cores to the price range. Maybe in normal life there is, but in our data set there is not. So the data set that we have, the number of cores apparently doesn't affect that. So there's no strong correlation between them. So yeah, this is a bit fishy because common sense says that there should be a correlation. So maybe our data is missing, or it's not well representative of the real world, which is fine. It happens sometimes. Sorry. Moving on. Last step is the amount of RAM on the price range. Amount of RAM, is it RAM? Wait, what's the column name? RAM, right? Okay, perfect. So RAM, let's, sorry. Yeah. So let's do the same for RAM and price range. Okay, so here, this is super interesting, right? Because this is super clear correlation. You can see that the lower amount of RAM, it starts like for the low cost, you have a lot of phones with 500 megabytes of RAM, and then it stops maximum at 2000. Whereas the high end, the RAM starts at 2000, right? And it goes up. So in this case, there's a very clear correlation, like literally a linear correlation between the amount of RAM and the price of the phone, okay? So this is very, very, very clear. And it makes sense, right? There's some sense to what we're saying. Now, one last step is if you would like to see the correlation between all of your different features, you can do what we call a heat map. So you can call df.corr, this CORR function that computes a correlation between all the variables against each other. And then you can use SNS, which is basically a library called Seaborn. You can use Seaborn to draw this in a heat map format. And I will show you how it looks like, because it's very interesting. So this is the heat map that we see. And it's important because you can see here all the columns or features, and we can see them again on the x-axis. And obviously, every feature is correlated 1% or 100%, sorry, with its own feature, right? So battery power is correlated 1 with battery power, or 100%. And that's why the diagonal is all 111. So it's 100%. But if you look at, let's look at the last line, because what we care about is the price range. This is our target variable. And we want to see which features would correlate the most with the price range. Okay. So if you look closely, if you remove the price range, obviously, we have the RAM 0.92. Then we have battery power 0.2. And then we have pixel width and height 0.15, 0.17. And the rest are very low, right? If you notice, guys, 0.02, 0.006, 0.01. So, of course, the number, the highest, the closest it is to 1, the better. So, so yeah, it's very, most features do not correlate with the price range, except for the RAM, which highly correlates, and the pixel width, px height, px width, and battery power. This is what I can deduce from looking at this. Hopefully, I did not miss anything. But the point is, you can see which features correlate the most, to know which features to keep and which features to remove. So in the feature selection step here, now that we know that a lot of features do not correlate, why do we need to complicate our model? We're going to decide to select only the features that correlate more than 0.15 with our data set, target variable. So we're going to do like a small condition and select from all the features, the ones that have more than 0.15 as correlation score. Okay, so we run the code here, and it tells us that we have battery power, pixel width, and RAM. These are the 3 columns or features that correlate with our price range more than 15%. So we're going to use only those 3, and we're going to drop everything else because it makes more sense. So we don't want to complicate our data for no reason. So next step is we need to normalize the data before we feed it to our model. Normalizing the data means instead of having each data with its own range, okay, so let me show you something. If I write df.describe, okay, okay, let me show you this. So the battery power has the minimum of 500, the minimum value of the battery power, and the maximum is 1,998. The blue, which is a yes or no, has a minimum of 0, maximum of 1. The clock speed has a minimum of 0.5, maximum of 3. So every category or every feature has a different range of values. If I feed them as they are to the model, I'm going to be biasing the model towards a specific feature. So what we do is we normalize them. We put them all between 0 and 1. Okay, that's what normalizing means. So the way we do that is we divide every column by the maximum of that column. When we divide the column by the maximum, we're kind of normalizing it. And we also have to separate the features from, like the input features from the output feature. So my input features, the X, will be basically those 3 columns: battery power, px width, and RAM. So I just have to select them from the data frame. So battery power, comma, px underscore width, comma, and then RAM. And then for the Y, I'm just gonna take all the rows and then -1, which is the last column. So from the data frame, I selected those columns to be my X, and for the Y, it's just another way to select the last column. Of course, I could have easily done something like this, which basically says price range, right? It's the same way, just to show you how things are done in Python, or how you can do things in different ways. So we can use the iloc function to slice the data frame to take all the rows. So semicolon means take everything on the row side, but on the columns, take only the last one, the -1, the last column at the end. And then we divide X by X max. So we divide every column by its maximum, and we'll end up with this mini data frame. You can see now, data frame, instead of having 21 columns, it has 3 columns. And the values are all between 0 and 1. And before we go to the modeling part, one last step is to divide the model between training and testing. So I'm going to take 20% of the data set to be used for testing and 80% for training. And I use a function called train test split that automatically splits my data between X train, X test, Y train, Y test. So input for the training set, output for the training set, input for the testing set, output for the testing set. And that's it, basically. I hope things are clear and they're not confusing to you guys. Now we finally reached the model, the predictive modeling part. I'm going a bit fast because I want us to finish on time, but hopefully everything is still clear and you guys are following through, and you have no questions. So we're gonna try the KNN, okay, which is the K nearest neighbor. So KNN, first of all, we have to we import from scikit-learn.neighbors, we import the class called KNN, or sorry, K neighbors classifier. Then we have to define the model. So KNN equals K neighbors classifier, and then we create the class, and you have to specify the number of neighbors. So n underscore neighbors equals 5, let's say. Yes, what we did so far, Bashir, is not really clean, but rather we explored the data. We decided that most data or most features do not correlate with my output feature. So I dropped them. I took the 3 columns that correlated the most, and now I split them, and I'm going to train a model with them. Why did I split them? Because I wanted to train my model on the training set and then have a piece of the data that I can use to evaluate the model. Okay, I need to see if the model learned well or not. So I use it with a data that it has not seen before. Like I'm giving the data or the model like a quiz or test. So I create the KNN model, and then I have to call model.fit, and then I pass it xtrain, comma ytrain, which is the training data. And then the model would basically train. It's that fast. To get the accuracy, I call knn.score, and then I pass xtest, comma ytest. So the model has trained. Let's test it on the testing set. Let's print the accuracy. The accuracy is 87.2%, okay, or 0.87. We can also do something called the confusion matrix, which I don't think we have time to explain it, but I'm just quickly gonna plot it. Confusion matrix basically says that how many classes that were actually 0 and that were predicted as 0, which are 94, how many classes that were 0 and were predicted as 1, how many classes were 0 predicted as 2 or as 3. So you can see where the model is confusing. This is called a confusion matrix. You look at the ones at the diagonal, these are the correct ones, and the others are mistakes. So for example, we have 7 examples of labels being 1, but being predicted as 0, okay? 8 being predicted as 2. That's how you can explain it. So the data was already mined and cleaned, and now we are, yes, exactly there. Now we are doing the predictive modeling step. So this is the first model. We got 87%. Now let's try the logistic regression model. Similarly, we import the model from scikit-learn. We initiate a new instance of that model, and then we call same thing, model.fit, xtrain, y train. We train the model, and for the accuracy, also same thing, linear regression dot score, x test, and y test. Okay, and then for the confusion matrix, I'm gonna copy the same thing. So you can see here the model is 89% accurate, and for the plotting the confusion matrix, we just have to remove, plug in the right model name, and you can see this confusion matrix. So you can compare how that this one is slightly better than the other one. And finally, guys, we have the decision tree. Okay, let's do that before we wrap up the workshop. Decision tree is about, we import the decision tree classifier, we define the instance, and we say max number of leaves equal 5. So don't go more than 5 steps. Okay, then d3.fit xtrain. It's very easy because they all have the same syntax. Model.fit, model.score. So nothing the same syntax. After the model has trained, because it's really quick, we can call d3.score, pass it x test, y test, and then we can see the score of the model. Same thing for the confusion matrix. We just have to pass in here d3. Okay, and this is 76%. So this is the least accurate model. Now, before we wrap things up, I want to show you, I want to visualize the decision tree that we came up with. Forget the code here, but at the end of the day, we're going to visualize it. And this is what the decision tree looks like. Okay. First of all, you can see that we're splitting on the amount of RAM. So is the RAM less than or equal to 0.55? If yes, then go here. If no, then go here. Next step is the RAM less than 0.27? Yes, go here. No, go here. If it's more than 0.5 but less than 0.7, then go here. Otherwise, go here. It's as simple as that. And when I scroll down a bit, you can see that. Let me zoom out a bit. Okay, you can see that low cost, medium cost, high cost, very high cost. So it all boils down to the RAM. So it has learned that if the RAM is less than 0.2, it's a low cost. If it's between 0.2 and 0.5, which is in this case, it's a medium cost. If it's between 0.7 and 0.5, it's high cost, etc., and very high cost. And this brings us to the end of the workshop. We haven't finished the session, just the hands-on part is done. I'm sorry, we don't have time to explain the Genie. This is basically some mathematical parameter that that the decision tree algorithm uses to make those decisions. Don't worry about it. What you need to focus on is the RAM part, not the Genie part. If you're interested, you can read more about it online. But again, this is not the place to explain it. It's a bit too complicated because we have to go through the logic of how this works. Since the RAM has the highest correlation with the price, the condition in the tree is set on the RAM. Technically, yes, but if we had 2 or 3 high correlated features, we would have gotten different conditions based on the others as well. But it was easily done because it was only one highly correlated feature. So Karim said, why do we need XCV and YCV cross validation? Where did you see cross validation? I don't know what you're talking about because we did not do any cross validation here. So I'm just checking if I added something by mistake. Okay. Is everything still clear? Are you guys still following? Things are still good? Because this is the end of the hands-on part. I really encourage you later on to repeat the steps at your own time, go through everything, make sure you understand everything. If you have some questions later on, you can always reach out to us and we'd love to answer those questions. But because I don't want to keep everyone waiting, let's go back to the slides. Let's go back to wrapping up today's webinar and kicking off the discussion panel. So we were at the hands-on workshop part. And yeah, congratulations, guys. You did it. You actually kicked off, or you did the first step in your journey towards AI. Of course, it's not perfect. Of course, you're not expert now, but together we were able to clean the data, process it, understand the steps, and build initial models. When you repeat everything at your own time, you will see that things make more sense. Today, we had to rush through things. So that's why you might feel that I didn't understand everything and I didn't grasp everything. But I assure you, if you repeat the workshop, you rewatch the recording and you repeat the steps, you will have completed everything. And now, if you'd like to receive your certificates, Noor or Larissa will send you a link in the chat, or you can just go to zaka.ai/Valentine gift, and you can fill a form and you will receive your certificate that you can share it anywhere and put it on your CV. But we're not then done yet, because I have a couple of things to tell you guys before you open up the Q&A, and I really hope that you can give me 5-8 more minutes of your time. But first of all, are you guys excited about everything you've done, or does it feel a bit overwhelming and your head is exploding? Because I know it's the end of the day and it's getting late. We've talked about everything, but I really hope that you're excited, because I have some exciting things to tell you. Okay? The exciting thing to tell you guys is that you're here because you're interested in learning AI, and you're here because you would like to take that step. So let's say you are currently on this phase here, and this is where you want to be, right? You want to be practitioners in AI. You want to be people who understand and who can build models. And there's a gap between where you are and where you need to be, right? This can be a gap of knowledge, time, information, financial gap, whatever it is that's keeping you from being where you want to be. But I'm here to tell you and to push you that you should take this leap and you should jump over the gap and you should, make it to the other side, because it's worth it. Why is it worth it? Because there's a lot of opportunities out there for AI jobs. Okay, if you look at the AI field in the last 5 years, let's say, there's a lot of positions that have come up. You can work as data scientists, you can work as data engineers, you can work as data architect, data analyst, ML engineers, ML research scientists, ML ops engineers. Every couple of months, we see a new position opening up under the AI umbrella, because this field is growing, it's booming, and there's a lot of demand for it. So if you take this gap and if you learn, there's a lot of opportunities there, so it's worth it. And how can you start with AI if you have zero previous experience? Well, obviously, you can go online. There's endless resources online. You can find courses, you can find projects to work on, competitions, you can find online free books, webinars, YouTube channels, ebooks, podcasts, whatever is the format that you like to learn in. You can almost find resources in that format. Most of the time they are free, or they're minimally expensive, and you can go there, you can work on yourself, read, apply, and go through the steps. What you also need, in addition to the technical knowledge, you also need to have a couple of what you call soft skills. Okay, you need to have a lot of patience, guys, because that not only is the field big, but it's also includes a lot of trial and error. So you have to try, and keep on trying. And you need some patience to do that. You need some resilience, because you need to jump on things and not to be afraid of failure. You need to have curiosity to actually go and learn things, and creativity as well. Okay, so these are some of the characteristics that I found to be very useful for someone working in AI or data. And now I'm going to focus about you specifically, and you as people who are currently live with us at this workshop. Because you joined us live, I want to make sure that we're giving you the value that you need, and we're really clarifying things for you. Okay, so what are the steps that you guys can take to to achieve the step or to start in the field. As I said earlier, you can go online. There's plenty of resources. There's plenty of stuff you can go through, and they're all great. The only problem that we find online is that it can get a bit confusing and overwhelming to have all those resources that you can go through. Okay, and a lot of people come to us and ask, what is the easiest, simplest roadmap to go from zero to literally becoming heroes in the field of AI? How can I take this shortcut instead of taking all those turns and go through this course and watch this YouTube and read this book and whatever? And this is something we've seen a lot. So I'm here to tell you that we have a program at Zaka called the Artificial Intelligence Certification Program. And this program is meant to give you a shortcut from literally zero to becoming hero in the field. Okay, and I need 2 minutes to tell you more about this program before we do the draw and we award one lucky winner free access to this AIC program. So what is this program about? The AIC, or the AI Certification Program, is an online program with a 16-week duration, and it has 3 career tracks. The goal of this program is to graduate you with market-ready skills in AI, meaning that we will give you the training and the skills you need, the practical skills you need to become market-ready, to become ready to find a job in the field. As I said, it's over 16 weeks long. We have 3 career tracks. So you join the program, you pick one of the following tracks: machine learning engineer, data scientist, data engineer. These are the 3 careers that you can work in if you join and finish the program. Okay. As I said, the program is practical, it's hands-on, and it covers a lot of tools from Keras, Python, TensorFlow, Jupyter Notebooks, OpenCV, MLflow. Data science includes some tools like Kafka, Spark, Hadoop. For data engineering, you cover Airflow, Snowflake, Flink, Databricks. So again, every track has its own tools, but they're all focused on getting you ready for the job market. I see in the chat that some people are facing issues with the link. Probably there might be some issues on the website. We are working to solve them. Don't worry, guys. You can repeat it. You can go to the link later on. It will still be valuable. Focus with me so that we can wrap up this webinar. So to quickly recap and tell you about the price of this program, what does the AI certification offer you? You get 10 weeks of technical training. Okay, these are basically online courses and sessions that you do live with the instructors. You get a capstone project that we help you work on with round-the-clock advising. We connect you with companies that will provide capstone projects for you to work on. So these capstone projects are projects for companies that you engage with. You get weekly office hours and instructor support live with our instructors every week. You have 3 weeks focused one-on-one mentorship for the projects at the end of the program. You also get a soft skills track. This is very important. We will not only train you on the technical skills or the AI stuff, we will also help you on the soft skills side. So we have a soft skills track, workshops and career development services to help you build your CV, to help you build your LinkedIn profile, to help you apply for interviews. We help you with mock interviews. We even connect you with opportunities when you graduate. We have a career fair. You get to meet recruiters. You get to present your project. You get to share your CV. So we facilitate the job placement, after you graduate from the program. So all of those features and all of those things, you can get them. We have the total value of the program is a bit less than $3,000. So it's $2,967 for everything, for you to go from zero to becoming heroes in the field and potentially landing a job in the field. So who can attend the AIC? Who is this for? It's for people who are looking to upgrade their skills and land a job in machine learning, data science, or data engineering. It's for people who want to transition into the AI field and are wondering where to begin. They don't know how to, where to begin or how to take the next step. Or if someone is already working, you have a job, you have a company, you're working on something, and you'd like to introduce cutting-edge technologies like AI to your workspace, this program is also for you or for your employees. And because you guys joined us today in the webinar, we always give people who join us a discount. So right now, you can benefit from a $500 discount to the initial full price by scheduling a call with our team, which will send you the link in the chat, or it's basically zaka.ai/support. You can go there, you can schedule a call, and you can redeem your discount. And by the way, if you're a fresh graduate, because we know fresh graduates cannot afford to pay even with the discount, the price. If you're a fresh graduate, we have a special offering for you that includes you paying a small fee, as a commitment fee to join the program. And then after you graduate, and only if you find a job in the field, you will pay us a fee equivalent to 1 month of your salary. So we really want to make sure that the program is accessible to everyone. And this offer is only for graduates, people who have just graduated and are unemployed and looking to find a job in the AI field. All of those details, you can discuss them with our team after today when you schedule a call. And if you're interested, even if you cannot afford to pay or worry about the scholarship or finances or whatever it is, I encourage you to start your application process today. Even if you don't know what you can do with the pricing, we can discuss that at a later stage. But first, figure out if you have the right background to join. So if you go to this link, aic.zaka.ai, you can learn more about the program, and you can take an assessment, a free assessment, that's gonna make sure, that's gonna tell you if you have the right background to join or not, okay? This is the end of today's presentation. We still have, before we wrap up, we still have to do the draw. So just hang with me for a second. Let me refresh the link. Okay, that's not the correct link. Can you send me the link, please, to do the draw? Okay, so let me answer some questions while someone sends me the link. Data engineering is under computer engineering. I don't know what you mean by under computer engineering. It's actually a booming job position under AI about basically building the pipelines for data scientists and machine learning engineers to build. Okay, this is not working, Noor. I think there are no names here. Okay. So to answer the question, data engineering, as I said, it's about building the pipeline for data scientists and machine learning engineers to work with data. So you collect data, you scrape the internet, you save data, you stream data. All about working with data infrastructure. To receive the recording of the session, Ali, you will receive an email later tomorrow, I think, with the recording. As long as you registered for this webinar, you will receive this by email. Any news about the draw?
Yes, I shared the link with you, Chris.
I think I clicked on it and it's not working. Maybe
I can share my screen. And
okay, share your screen, and maybe you can do quickly the draw. I need to take a 2-minute break, and I'll be back to answer your questions and for the Q&A. But if you guys just give me a 2-minute break. Meanwhile, if you have any questions about the draw or anything else, you can ask Noor or Larissa.
Can you see my screen?
Yes, we can see it.
Yes.
It's all clear.
Okay. Well, congrats, Karim. Is Karim with us?
So guys, just so you understand, the person who would win the draw should be here. So if Karim is not here, oh great. It would be great if you can open the console if you're able to take a picture. And we will follow up, of course, with you to ensure that you meet the criteria of the program. So, so please let us know if this is what you're looking for. And thank you, everyone. Noor, can you just keep the screen share to take a pictures? Okay, great. So let's take. Yes, as for the website, I'm not sure why it's down. We will get back to you with the certificate by email for all the attendees who joined now. Okay. Do you have any question? It would be great if you can open the cam and interact with us and let us know if you benefited from the workshop. And of course, we will go over the questions to answer them in the chat. So if you have a question that is still, Chris didn't answer it, please drop it again because we're having a lot of questions in the chat. So the link I shared at the end is for the people who would like to redeem the support, the Valentine gift for the program. Feel free to schedule a call with me and I'll also be able to support you if your background is good to join. And for the link for the certificate, we'll share it again. Any more logistic question? I'd be happy to support.
The link opens and sign up for a Valentine gift, right?
Yes, the Valentine gift, we're checking just with the developer to check what happened. Sorry for that.
Yeah, it opens for me and a page for sign up for a gift of Valentine. Is it right?
Okay, it worked. Okay, great. Let me check again to confirm. So you have only a few steps to receive your certificates that you should do. Just let me check if it worked again. Okay, and for the questions, we will follow up for the recording. We'll follow up with you tomorrow with an email. Make sure you check your emails and we'll drop the recording. So feel free to maybe redo the workshop, the technical workshop, and maybe to take a screenshot of the results. I'm sure we'd love to check your results and if you manage to do the collab.
Thank you, Larissa.
So thank you, Chris. And thank you everyone for joining. If you can open the account, it'd be great. We can take a last picture with everyone. Thank you for sticking around.
Yeah, and if you guys have any questions, I think right now we can have a Q&A session. We can answer any questions you guys have. So I know that some of you asked questions earlier in the chat, but obviously I lost them. So if you can, if I did not answer you, please repeat your questions so we can discuss them now.
Great. Thank you, Lynn, Jihad, and Ali for opening the cam. It's really nice to see your face. Great, great. More people are opening.
Good to see everyone.
If we have a full screen, we'll definitely just take a picture.
Yeah, for sure. Yalla, guys. If you fell in love with machine learning, you have to open your cam and take a picture. Great. I see a lot of faces.
Okay, then, guys, the thing is just maybe drop the heart and we will take the picture because everyone maybe now open the cam. This is awesome. And take also the picture because not everyone can fit the screen. And here is my heart. Cheese. Smile, guys. Okay, good. And I want to also mention thank you for everyone who supported the event. I know there's a lot of people from Lebanese University, Fanar, from the IEEE. We have from SIAC, from Saudi Arabia. And thank you so much for supporting us and reaching more people and for joining. So I hope this was a beneficial session and workshop. And thank you, Chris, for the 2 hours.
My pleasure. I would love to get you guys' feedback if there's anything you did like or did not like about the workshop. If you have any questions, we can discuss that. I don't know if, okay, Muhammad said about the AI certification, can we pay a part and the rest after we get employed? Yes, Muhammad, there is this option for graduates. You can discuss these details with the team. Go to aic.zaka.ai, kick off your application process. Then we can discuss those things. Don't worry. I'm learning a lot of theory on machine learning, but I still struggle with implementation and coding. What do you recommend to speed up my learning curve for coding and Python specifically? The only thing I always recommend anyone who's learning is to, apply things, right? You cannot learn by watching videos and by watching courses or even webinars like this one, right? The only way to actually learn is by getting your hands dirty with projects, whether it's in coding or in machine learning. So yeah, to learn, try to apply projects, try to join hackathons to work on something, join competitions, come up with an idea and work on it. So that's the best way to learn. And while you're building, if you notice that there's something you don't know, you need to understand or to learn something to build it, then that's how you learn for the sake of building things, not just for the sake of learning and accumulating, certifications or whatever. It's all about building things. Should we learn in depth all of AI, ML, DL, and DS, or is it better to focus on one of them deeply? I mean, you cannot do that. It's very difficult actually to learn everything about the whole field. It's a very big field, and the field is growing. It's advancing. If you pick deep learning and let's say I don't know, computer vision, a lot of things are happening every day and every now and then. So you cannot stay on top of everything all the time. So of course, it's good to have a good foundations of everything, but then pick something and dive deep and specialize in it. It makes more sense. How do you recommend choosing between a career in ML or data science? I don't really recommend. It's up to you. So just to be clear, a lot of companies confuse ML and data science. So you can find a company that's hiring a data scientist as a position, but in fact, they're doing the role of a machine learning engineer or vice versa. But whenever companies have both like data science and machine learning, it's usually data science work more with the data. They work more on the modeling side to build basic models, but machine learning engineers are more on the deployment side. They take those models, they deploy them, they integrate them with the product, they scale them. So it's more of an engineering side of things. So if that's the case, I think it depends on your background and what you like more. Data science is more background in math and statistics and less in coding. It doesn't require a lot of coding. Versus machine learning engineering, it's more like coding. You're basically a software engineer who knows ML. So this is kind of how to help you decide between both of these options. Is a master's degree essential to work as a machine learning engineer? No university degree is essential to working as an engineer, as a machine learning engineer. There's a lot of people who, you can learn things without going to university or to take any degree. Of course, master's degree or university degrees help you in a lot of things other than that. So they help you build a good foundations, the good structure. They help you figure out how to learn and a lot of other skills. But technically, you don't need them. Nothing is essential. No certificate is essential. What's really essential is practical knowledge and practical experience. So if you can prove to a recruiter that you have practical experience in building machine learning projects, you're hired. No one's gonna look at the certificate or a degree. What part of engineering is better in your opinion? That's a very broad question, Tala. I don't know what you mean about what part of engineering. It's a very broad question to be able to answer it. I'm sorry. Please can give relation between ML and CBR algorithm. What is CBR algorithm? Can you be specific, Nadir? I have a specific question. What did we expect this of right now is a very small model, so we can try out everything and it looks simple. But how about when I'm going through big data that takes a lot of time to train the model, so I can't really try and error a lot? How can I know my work so far? You cannot, Bashir. It's one of the things about building deep learning models. So of course, as you saw today, training a model took less than a second. But when you're talking about deep learning models, when you're talking about training deep learning models on huge data, you're talking about hours, days, sometimes weeks of training. So that's why there are things that you can do to monitor the performance of your model training as it's training. You don't finish it. You don't wait until it finishes to get the results. You can I'm not going to go into the details now, but you can monitor the training process as it's going and figure out if it's doing well or not before it ends. But of course, there is a lot of trial and error. There's a lot of time wasted. I've trained a model and then it's not good. I have to train it again. So you still have those issues, of course. Thank you, Karim, for joining. I'm happy that you enjoyed it. The link for the certificate, I think someone sent it earlier. Please send it again. Zaka.ai/ I think it's Valentine-gift. But
this it's still not working. We will send them an email.
Okay, it's gonna be sent in the email. Yes. So don't worry, guys. Tomorrow you will receive an email that has the recording, that has the link to the GitHub repository, that has all the links that we've shared today for the support, for the certificate, for the AIC application. Everything is gonna be in that email. So just wait for the email and you will have it. What about the certificate? I don't know, Jad. What about it? It's not. I didn't understand your question. Sorry. Case-based reasoning algorithm. I'm not aware. I'm not familiar with case-based reasoning, Nadir. I'm sorry, but if I would take a guess, I would say these are coding algorithms. They're not machine learning algorithms, which means they are based on logic, based on if-else conditions, and not on data. If I would take a guess. Are we going to receive certificate by email? If an ML engineer jobs require to have skills in data engineering, why separate them? It's not. ML engineer job does not technically require. So again, guys, here's the idea. 5 years ago, a company would hire a data scientist that would collect the data, clean the data, save the data, process the data, build a model with the data, integrate the model simply in an application, right? There used to be one job to do everything. But then the field became too big. It became too complicated. It became too mature. It has a lot of tools, a lot of things. So when it's expanding, instead of having one person that does everything, you now have someone just working on the data, someone working on the modeling, someone working on deploying. And that's how you end up with data engineers and ML engineers. So of course, yes, sometimes you might find someone who does everything. But today, in today's world, to really say I'm an ML engineer and I'm a data engineer at the same time is a bit difficult because ML engineers have tons of frameworks and tools to be able to understand and work with them. So to cover all those and to cover all the tools of data engineers and to be really proficient and experts in them, it's not that easy. So, so they do not require them, right? You can know both. Of course, there's a lot of overlap, but it's better to focus on something. So to specify and to dive deep into something. Thank you, everyone who's saying thanks and sharing feedback. Let me know how did you find this workshop? Was it interesting? I don't know. Any feedback, positive or negative, is useful for us. Thank you so much, Salam. Thank you, Marianne. Happy you enjoyed the workshop. Does the AI certificate help us to get hired in large IT companies? So currently, we are not connected to any of the FANG companies. We are working towards having some connections. We do have a partner network of companies that do include small startups as well as large regional companies. So you might end up, landing a job there. We don't have a connection to a FANG company yet, but hopefully we're working towards it. So maybe soon. Yes, Wasim, definitely it was fast. I do apologize for that, but honestly, guys, what we covered today in 2 hours, people cover it in like, I don't know, 5-6 hours minimum. So I really saved you time and gave you like highlights. Of course, that's not how we do things at Zaka normally. our courses are more relaxed and they're focused more on practical stuff. This is just to kind of give you like a teaser, right? It's like you've watched the trailer. Here's what you can expect. Now go watch the movie. That's the idea behind it. And I hope you enjoyed the trailer. Thank you for people sharing feedback about the workshop. I'm really happy you guys enjoyed it. Thank you, thank you, thank you. Awesome. I'm very happy. If you have any other questions, the program is live, remote, or on site. That's a good question, Leah. Everything we do at Zaka is online. It's all an online program. Online does not mean self-paced. We don't believe in self-paced learning by itself. So our programs all run the following way. It's cohort-based. So the program starts on a specific day and ends after X weeks. And you have the option. The content is self-paced, so you have the option to go and watch it whenever you'd like during that week on the platform. But at the same time, you have to join live sessions with the instructors over Zoom. So it's a mixture between self-paced effort and live instructor-led effort. This way, you get flexibility to watch the content and to work on the assignments at your own time, as long as you finish them before the deadline, of course. But you also get live instructor-led sessions like this one with instructors over Zoom to ask questions and to interact with them. Can you do it while you're in university? Yes, you can. It's not easy, but yes, you can. The program is a part-time program. It requires roughly 20 to 25 hours per week of your time. Of course, if you'd like to dive deep and go into everything, it can take much more than that, but sometime around 20 hours per week or 25 is enough. Can you please make a brief about machine learning? We've been talking for 2 hours about machine learning, Marianne. The brief would be, it's a collection of algorithms. It's a group of algorithms that take data as input and process data to extract patterns from that data. This is like a very quick intro about it. Can a math student continue his studies in machine learning fields? Yes, definitely. However, Maria, do work on your programming skills. If you'd like to become a machine learning engineer, you definitely need programming skills. And the more these skills are advanced, you need the skills of a software engineer to become a successful machine learning engineer. If you know basic scripts and coding, you can definitely work as data scientist. But if you want to become a machine learning engineer, you need some software skills for sure. Any other questions? Anything you'd like to ask or tell me or share? Do you need data structures? Yes, you do. I'm assuming, wait, your question was, definitely you need data structures for sure, because you're dealing with data, right? You need to save data in the right way. At the end of the day, guys, the 3 career tracks that we cover are technical tracks, right? Soon enough, we are planning on launching a data analyst track that does not require coding and is non-technical. But everything that I'm talking about is a technical track, which means that it requires coding and some level of understanding of how computers work, right? So data structures is definitely one of them. Is it enough to have a CS degree to be a data analyst? Yes, it is enough, Aya. Does mechatronic engineering and machine learning are related? Yes, they are somewhat related, but mechatronics, they're more into the hardware side of things. They definitely use machine learning to add smart features to their to the robotics side of things, for sure. And as I said, they all fall under AI, so there's a lot of overlap and interconnectedness between these fields. Any other question, guys? Is there something you did not enjoy, apart from the links not working on the website? What would be better background for becoming a machine learning engineer, CS degree or computer engineering degree? Maybe a computer engineering degree, but Bashir, I think so. You know what? Actually, I'm not a big fan of degrees in terms of only the degree. I would say both degrees are good as long as you have a good, solid background in programming. So if you work on your skills, if you have a good skill set, then no matter which degree you can work on. I want to tell you something, guys. Some of our graduates, we had a person coming from agricultural engineering. We had someone coming from petrochemical engineer. We had a mechanical engineer. We had a civil engineer. Those are actual people who have taken out our courses and are now working as machine learning engineers. So just to give you an idea that don't be fixated on which degree or which, it's all about how much you're willing to learn and the skills you're willing to learn. So I'm telling you what are the skills. They're programming, they're data structures, etc., etc. Learn them no matter your background, and you can be working in the field. Does C language needed in AI? It's too specific, Muhammad. AI is the concept, right? You can, most of the people coded in Python, but you can find libraries in almost any language you have. So you can use C to write AI, but you can also use Python or anything else. It depends on what you're trying to do, actually. Okay, great. Did I miss any question? I think I answered everything. Thank you so much, guys, for joining. It was a pleasure. Thank you for joining us on Valentine's Day. Hopefully hope to be able to see you again in a future webinar or some of the competitions we do or some of the courses we have. If you go to our website and you sign up, it's a free account. We do have some basic courses for those of you who don't know Python or don't know programming. We do have some very basic courses that can put you on track. And we're looking soon to release more of these courses, so keep an eye out. Do register for our newsletter to keep, to stay updated with our events and activities, and follow us on social media. That way you can reach out for any questions. If you need anything, you can reach out to me. Even you have my, I think you have my profiles. You can reach out, ask me anything. I would love to help you and support you on your journey. And yeah, that's what we do. We help spread AI awareness and get people to join the field. So thank you again for joining. I'm just talking in case someone remembers they have a question. Otherwise, we can wrap up and go enjoy our Valentine evening. Everything will be received by email.
Thank you, everyone.
And if you have
Thank you,
further questions, you can reply to the email and we'll support you. All right. Thank you, guys. It was a pleasure. Enjoy your evening, and we hope to see you soon. Bye, guys.
Bye.